Your SIEM shows a Windows host started a strange command line at 2:14 a.m. Native logging confirms a process started. That is not enough. You need the hash. You need the parent process. You need to know if it made a network connection, wrote a file, or resolved a suspicious domain. Without that context, the analyst is guessing. With Sysmon, the endpoint becomes a sensor, not a magic box, a better witness. Sysmon is a free signed Windows system monitoring tool made by Microsoft. It records detailed endpoint activity that normal Windows logs often do not capture cleanly. In plain English, Sysmon writes better security events about what programs did on a Windows machine. Those events go into the Windows event log, then your log forwarder ships them to the SIEM. In NIST-style terms, it supports the detect function. It does not prevent activity by itself. It gives defenders richer signals so they can find, validate, and investigate suspicious behavior faster. Life before Sysmon is noisy and thin at the same time. You may know that a process started but not have the file hash. You may see a login, but not the chain of programs that followed it. You may get a firewall log showing an outbound connection, but not the exact process that opened it. That gap slows the SOC. Analysts jump between hosts, tickets, firewall logs, and endpoint consoles just to answer basic questions. Sysmon closes many of those gaps by adding process, file, DNS, and network context where defenders need it most, tied to the endpoint, and ready for the SIEM. The mechanics are simple. You deploy Sysmon to Windows endpoints. You load a configuration file. That config tells Sysmon which activity to record and which activity to ignore. Sysmon then writes events into its own Windows event log channel. Your normal log collection path forwards those events to the SIEM. The important events for most SOCs are Event 1 for process creation, with hashes included, Event 3 for network connections tied to processes, Event 11 for file creation and writes, Event 22 for DNS queries. The install is easy. The config is where success or failure happens. Here is a common SOC workflow. An alert fires because a user workstation runs an unusual command shell from an Office application. Event 1 shows the process name, command line, user, parent process, and file hash. The analyst builds the parent-child tree and sees the Office app launched the shell, which launched a scripting process. Event 22 shows a DNS lookup seconds later. Event 3 shows the same process opened an outbound connection. Event 11 shows a new file written in the user profile. Now the analyst has a timeline. They search the SIEM for the same hash, domain, and parent-child pattern across all hosts. Sysmon strength is context. Event 1 gives process creation with hashes. Event 3 ties network traffic to a process. Events 11 and 22 add file and DNS visibility. Parent-child process trees transform triage because they show sequence, not just isolated events. But Sysmon is not an EDR replacement. It does not block by default. It does not investigate for you. It does not decide what matters. A bad configuration can flood the SIEM with low-value noise or miss the events you care about. Treat Sysmon as high-quality telemetry. The value comes from collection, filtering, detection content, and analyst skill. Sysmon sits close to the endpoint, but its main value often appears in the SIEM. The SIEM correlates Sysmon events with identity logs, VPN activity, proxy records, cloud logs, and asset data. UEBA can use Sysmon fields to learn normal process and network behavior for users and devices. EDR may already collect similar telemetry, but Sysmon still helps when teams need portable, transparent logs with known event IDs. It is also useful in labs, smaller environments, and high-value server monitoring. Think of it as endpoint evidence that strengthens correlation, hunting, and incident review. Do not write a Sysmon config from scratch on day one. Start from a respected community baseline. Review what it collects and what it excludes. Pilot it on a few test workstations and servers. Forward the key events first, 1, 3, 11, and 22. Confirm the SIEM parses the fields you need: image, command line, parent image, hashes, destination, query name, and user. Then, tune with the analysts who will use it. Learn Windows process basics, parent-child relationships, hashing, DNS investigation, and SIEM search. Your goal is not more logs.
Recap in 3 beats.
First, Sysmon turns Windows endpoints into useful security sensors by adding process, hash, network, file, and DNS context. Second, the configuration makes or breaks the program. Start from a community baseline, then tune for your environment. Third, Sysmon becomes powerful when the SIEM connects its events to identity, network, cloud, and asset data. If you are building detection coverage, learn Event 1, Event 3, Event 11, and Event 22 first. Subscribe for a new Security Tools Decoded episode every day, plus the daily ranked CVE brief on this channel.